Hello friends, welcome to my YouTube channel JK Academy India. In this video, we will discuss the types of generators. DC generators are classified according to method of their field excitation. So on the basis of this criteria, they can be classified as separately excited DC generator and self-excited DC generators. In self-excited DC generators, they are further classified as shunt wound generators, series wound DC generators, and compound wound generators. And again, in compound wound, there are two types of generators. One is long shunt compound wound generator and other is short shunt compound wound generator. Except the above, there are also permanent magnet type DC generators. In modern alternator, a PMG is connected or coupled with the AC generator to generate power. So in such type of generators, the magnets are permanent magnets, but in above cases where separately excited or self-excited, the field is excited by an external source of supply or by an internal source of supply. In these generators, means PMG, no field winding is placed around the poles. These machines have fairly constant magnetic field, although these machines are very compact but are used only in small sizes, like dynamos in automobiles. In automobiles, to charge the battery and to supply power for lighting, dynamos are used, and dynamos are nothing but the permanent magnet type DC generators. The main disadvantages of these machines is that the flux produced by the magnet deteriorates with the passing of time, which changes the characteristics of the machine. Now, the separately excited DC generators. A DC generator in which current is supplied to the field winding from an external DC source is called a separately excited DC generator. So this is the field winding of the shunt DC generator, and it is excited through this battery via a variable rheostat to control the field current. The flux produced by the pole depends upon the field current within the unsaturated region of the magnetic material of the poles. Phi is directly proportional to field current flux, but in the saturated region the flux remain constant. Its conventional diagram is shown here. Important relation here, Ia equals to IL, armature current. This is Ia and this is the IL. So IL is being supplied to the load passing through the armature. So IL is equals to Ia and terminal voltage V equals to Eg minus IaRa, where IaRa is the voltage drop across the armature. Ra is the resistance of armature winding and Ia is the current passing through the armature. Now one more voltage drop is added. Suppose we know the brush voltage, contact brush drop, so we can add here 2 VB for the two brushes as shown here. Now the power developed equals to Eg into Ia. Eg is the EMF generated in the generator and Ia is the armature current. So the power output by the generator will be V into IL, and it is also called V into Ia, which is supplied to the load connected across armature winding. Now the self-excited generator, a DC generator whose field winding is excited by the current supplied by the generator itself, is called a self-excited DC generator. In a self-excited DC generator, the field coils may be connected in parallel with the armature or in series with the armature, or partly in series and partly in parallel with the armature winding. Accordingly, self-excited generator may be classified as the shunt generator, series wound generator and compound wound generator. In case of shunt generator, the winding is connected in parallel. In case of DC series wound generator, the winding is connected in series, field winding. In compound wound, partly the winding is in parallel or partly it may be in series. Now the first one in the self-excited DC generator is the shunt wound generator. The field winding is connected across the armature winding, forming a parallel or shunt circuit. Therefore, full terminal voltage applied across the field winding. So this is your field winding. A very small current ISH flows through it because this winding has many turns of wire having very high resistance RSH of the order of 100 ohm. Its conventional diagram is shown here. Important relations are shunt field current ISH equals to voltage applied divided by the resistance of the winding. The field current is practically constant at all load. Therefore, the shunt DC machine is considered to be a constant flux machine. Here, IA equals to ISH plus IL. So, IA will be IL plus ISH and the terminal voltage V will be Eg minus IARA. IARA is the voltage drop across the armature including brush contact voltage drop, we can minus 2 VBA from this. So the power developed will be equals to V into IL. V is the voltage across the load, IL is the current passing through the load. Now the series wound generators. The field winding is connected in series with the armature winding, forming series circuit. This is your series winding connected in series with the armature. Therefore, full load current IL or armature current flows through it will be same. This is IA and this is your IL. Since the series field winding carries full load current, it has a few turns of thick wire having low resistance, usually of the order of less than 1 ohm. Its conventional diagram is shown in this figure. Now the important relations in series field, ISE equals to IL equals to IA, and the series field resistance equals to RSE. Terminal voltage will become EG minus IARA minus ISE RSE. And if we include the brush contact drop, we can minus 2 VB in the equation. Now the power developed by the generator will become V into IL or V into IA. Now the third type is the compound wound self-excited generator. In this, there are two types of field windings. One of them is connected in series having thick wire and few turns, and the other is connected in parallel having many turns of fine wire with armature. A compound wound generator may be of two types. One is the long shunt, in which the shunt field winding is connected in parallel. So this is the long shunt. This is the field winding connected in parallel across the armature and series field winding. The conventional diagram is shown here. Now the important relations, shunt field current ISH will become V upon RSH, and ISE or IA will be equal to IL plus ISH. This is IA, this is IL, and this is ISH. Terminal voltage V will be EG minus IARA minus ISERE, and if we know the brush voltage drop, contact drop, we can minus 2 VB from this equation. So the power developed by the DC generator will be V into IL. Short shunt, in which shunt field winding is connected in parallel with only armature winding. So this is the series field winding and this is the shunt field winding. Only shunt field winding is across the armature. That's why it is called short shunt. Important relations, IAC equals to IL. This is IL and current flowing through the series coil will be same. ISH will become V plus IL RSC upon RSH. V is the voltage across the load plus voltage drop in this winding IL RSC divided by RSH, the resistance of shunt field winding. So now IA equals to IL plus ISH, and V equals to Eg minus IaRa and IL RSC. Including brush contact drop also, we can minus 2 VB here, and the power developed or the power output by the DC generator will be the same. In all the cases it remains same. What the DC generator is giving output is nothing but the voltage across the load and current passing through it. Now we will see the voltage regulation of a DC shunt generator. At no load, the voltage at the terminal of shunt generator is maximum and is called no load generator EMF. When load is applied on the generator, the terminal voltage decreases due to drop in the armature circuit. Generated voltage or the voltage across the terminal Eg equals to E0 P phi Zn upon 60A as per the EMF equation. We have seen this equation in our previous video. At full load, the terminal voltage will be V equals to Eg minus IaRa minus Vb. Vb is the voltage drop at the brushes. The rise in voltage drop from full load to no load at constant speed of a DC generator is called voltage regulation, and it is expressed in percentage of the full load terminal voltage. So the percentage voltage regulation equation will become E0 minus V upon V into 100. Thanks for watching.